Welcome to Probamatica. I am Alfonso, doctor in pure mathematics. Here I show my process learning statistics. Today we are going to talk about Bayes' theorem, which consists of three things. The first one is that the probability of A given B is equal to the probability of B given A times the probability of A over the probability of B. The second one gives a way to calculate the probability of B, and the third one is a way to actualize the data if another thing happened beside B. So we start with the first one. Well, in the last video, remember that we saw what probability of A given B means. We also give as definition that the probability of A given B is equal to the probability of A inter B over the probability of B. Write this down because it's important. And with this, we had a property 2, if you remember correctly, which is what I'm writing here. You just solve the equation and you get 1. Write this down. Now we prove 2, which of course probability of B is equal to the sum of these two probabilities. It is like that because these two events give the whole B. Now we used part 1 with substitute and we get formula 2. So why this is important? Well, let's do an exercise, which is a school exercise. Before that, remember the formulas we have written down? Now we go for the exercise. A patient took a test for triskaidekaphobia. And he got positive. So the doctor said, the probability of having positive being sick is 95%, and the probability of being positive given non-sick is 5%. Now, if we suppose that the probability of being sick is 5%, what is the probability for the patient of not being sick given the fact that he got positive? So why this is a school exercise for me? Because the two probabilities, as the doctor are saying, are things that no one have interest for. Usually people have interest of what is the probability that I am sick given that I have a positive exam? Or what's the probability that I'm not sick given that I have a positive exam? That's what we usually care about. So I guess a doctor will say these two probabilities, not the other two. Do you know if pharmacists work with the other two probabilities? I am not sure. Also, how they are able to get these two probabilities. I think usually you make the probabilities out of the people that got the test, not out of the people that are sick or non-sick. So I'm not very sure how they get this probability, but we will suppose that these are correct. We will try to calculate these two probabilities using Bayes' theorem or using the formulas of Bayes' theorem. So we have these two things. We don't have the one below, but then we can use the second formula and we get the whole thing. Remember, P is positive and S is non-sick. S is sick. We got 1/2, so not bad. Maybe we don't have the disease. There is 1/2 of probability of we being non-sick and having a positive test. That doesn't sound good for the test. Maybe that's the reason why they decide to use the other statistics. Well, now that we may not have triskaidekaphobia, but we want to make sure, so we test ourselves again. And here is where the second formula is important, because the second formula allows us to update the previous test. So what the second formula says is what we write here. So we say that B is having a positive test, test 2 and test 1, and A being sick. We know the first one was 1/2, and we can calculate the rest as before. So with this, we have a lot of numbers, which we can then cancel many things out. This is what is left. We use the calculator to see. And we get a probability of 26%. So there is a probability of 26% of non being sick and having two positive tests. So the probability is not too high. We may have triskaidekaphobia. So now let's see why this second formula works. We have the probability of A given B and B2, but we have B1 and B2 being independent. We use the property, the first property, the first part of Bayes' theorem, but now we use that they are independent, and then the probability of A inter B is just the multiplication of the two probabilities. This thing that I am putting into dots, inside the dots, is the probability of A given B1, which is the third formula. So the third formula is true. So as a summary, we have that Bayes' theorem is a correct combination of the formula 1, the formula 2, and the formula 3. Write all this down because this could be important if you want to use Bayes' theorem. Now, see you triskaidekaphobist. Just remember that the event V, being positive, is equal to 13, and you may be afraid of the number 13.